So this is what we have. First of all, always you read the question, you identify the processes. What is the name of the process? Now the first question, it says 5 kilograms of a perfect gas expands. So the first process is a polytropic process. Expansion and is a polytropic processes. So when a gas expands, it means that the pressure decreases but the volume increases. So you start with draw, and then you draw a PV diagram. This is volume in cubic meters, pressure in kPa. So the name of the process is the gas expands polytropically. You draw a curve where you have P1 and then you have P2. So the sketch is incomplete because we do not know the name of the curve. And we also do not know whether it's in compression or it's expanding. So the question says the gas expands. If it expands, it means that the arrow is facing downwards, expansion. And the name of the curve is polytropic process. PV N is equal to C, where you have V2 and then you have V1, and then you have P1 and P2. So the sketch now is complete, and now we write down our data. It says 5 kilograms of perfect gas. 5, it means the mass is 5 kg. That is our mass. It expands polytropically from a pressure of 1 megapascals. From, which means from 1. In other words, your pressure at 1 P1 is 1000 kPa. It expands from 1 megapascals and the temperature is 300, the T1. T1 is 300, which is 573. 573. Now it expands from 1 megapascal to 200 kPa. So P2 is 200 kPa. And T2 is 165. 165 plus 273 is 438. T2 is 438 Kelvin. And then we are told that the specific capacity Cp is equal to 1.011 kilojoules per kilogram Kelvin. And then Cv 0.77 kilojoules per kilogram Kelvin. The question says calculate or draw a PV diagram of the process and calculate the following. The first one is calculate the characteristic gas constant. What is a characteristic gas constant? From PV is equal to mRT. So from this formula here, R is a characteristic gas constant. That's what the question is asking for. So in this case, we can say that P1 V1 is equal to mRT1. Do we have P1? Yes, we have P1. Do we have V1? No, we don't have V1. Do we have mass? Yes, we have mass. Do we have T1? Yes, we have T1. Therefore, we cannot use that formula because we have two unknowns. We have two unknowns. But if you look at your notes from last week, you also know that the difference between Cp and Cv is R. In other words, we say R is equal to Cp minus Cv. So Cp is given as 1.011 and Cv 0.777. So the difference between the two is 0.2334 kilojoules per kilogram Kelvin. That's the answer for the first question.
Sorry, sir.
Yes.
I just wanted to ask, for the tutorial that you have to submit, you said that you can work in groups. Must we submit it as a group or individual?
No, individually.
So we must submit it individually, but we can work as a group.
Yeah, you can work with your friends and then, but you submit your work individually. Yes.
Okay. Thank you, sir.
Yes. All right. Okay. Yeah, but guys, let's wait until let's finish the question before, because I think the question that he asked, that Mola he asked, is not relevant to what we are doing now. It's something else. But we can, after that, we can always come back and answer ask questions. So now we have R. Now question 1C says calculate the change of internal energy. We said that for all the processes, all except isothermal, delta U, the formula is the same, which is delta U is equal to mCv T2 minus T1. That is for all the processes except isothermal. So mass is 5, Cv is given, T2 we have, T1 we have. So when you substitute, the answer is going to be negative what? Negative 524 minus 524.48 kilojoules. That is what we have, because T2 in this case is what? T2 is 438. So 438 minus 573, it will give you a negative answer. So the answer is delta U is 524.48 kilojoules. Now the question says, question 1D, calculate the polytropic index of expansion. What is that? It's N. Calculate this N here. How do you calculate N? With the formula sheet you have, you will come across a formula P1 V1 N is equal to P2 V2 N. Ultimately, with your mass 1, N is equal to ln of P2 over P1 divided by ln of V1 over V2. We have P1 and P2, but we don't have the volumes. The volumes are not given. We have to calculate them. How do you calculate the volumes? Let's start with the V1. V1 is going to be P1 V1 is equal to mRT1. T1 is given, R is given, M is given, P1 is given. Therefore, V1 is equal to what? V1 is equal to 0.67 cubic meters. 0.67 cubic meters. Now that we have V1, we can use the same formula to calculate V2. And we already know our answer that if V1 is 0.67, V2 is going to be greater than that, because during expansion, pressure drops, volume increases. So from P2, V2 is equal to mRT2. We have everything except V2. Therefore, V2 becomes 2.56 cubic meters. 2.56 cubic meters. So now we have pressures and the volumes. And then you substitute all the values, your answer is going to be 1.2. That is your value of N, index of compression and expansion. Right. So the next question is going to be work done. Work done for a polytropic process is work done between 1 and 2 is P1 V1 minus P2 V2 over N minus 1. If you don't use the pressures and the volumes, you can say M R T1 minus T2 N minus 1. Now, because work is done by the gas, we are expecting our answer to be positive or to be negative. The answer must be positive because it's expansion. If it was in compression, our answer will be negative. So from that knowledge, you already know you have expectations about your answers. That okay, now because the gas is expanding from 1 to 2, our work done is supposed to be positive. So when you substitute all the values, your work done is 790 kilojoules, because now you have everything. When you have time, plug all those values here, see if you will get the same answer as when you use MRT. You should get the same answer. Why? Because P1 V1 is equal to MRT1. So instead of PV, you use MRT. So that's what we have done here. And the last question says the heat flow during expansion. So the heat flow during expansion.
Sorry, sir.
Yes.
For M, are we gonna use the 1 for the mass?
No, it's given. It's 5. Remember when? Okay, let's go up. Mass is given. Here is mass. It's given. Here is 5. So sorry.
All right. Thank you, sir.
It's given, yeah. And thanks for reminding me. So in most cases, you find that if mass is not given, you have to calculate mass. How do you calculate mass? You somehow will have information that will enable you to calculate mass from the first statement where you say P1 V1 is equal to MRT1. You will have T1, you will have R, P1 and V1, and then you calculate mass. Sometimes the question will tell you that per kilogram of mass. If they say per kilogram, it means your mass is 1 kg. And if it's 1 kg, all your answers are going to be in kilojoules per kilogram. Delta U will be kilojoules per kilogram. Work done, kilojoules per kilogram. Q, kilojoules per kilogram. But in this case, because we have mass, now our units are in kilojoules. So the last question is heat, Q, which is Q. So Q is delta U plus work done. Delta U we have calculated. Here is delta U. Work done, here is work done. So you add the 2, it should give you 265. So the answer should be 265 kilojoules. This is for one process. So what I want you to do, you can go home and then redo this question, make sure that you understand. And then you can move on to question 3. So the question 4, 5, 6, 5, 7, 8, 9, and 10. Now I'm going to do question 2. Question 2 is a cycle. This is something that I'm going to ask in the immediate test, a cycle. The question 1, this is just a warm-up to what we're going to be doing. Question 4 is still a warm-up. 5 up to 10, these are warm-up questions. So when we are done with this warm-up, we go to the real stuff, which is the cycles. The cycles are very, very easy. Just have your formula sheet in your hand, and then whichever process or the formula that you don't, just check. I'm telling you, by the time you do question 10, you won't be able to even use your formula sheet because some of the formulas will be in your head already. So the more you do, you practice, the more you understand. If you feel like these questions are not enough for you to practice, it's fine. Let me know. I'll give you extra questions for you to practice. Because at the end of the day, I don't want you to be sitting in the exam not knowing what to do. It happened last semester, and we are not about to repeat such mistakes. Right. So now let's have a look at question 2.
Professor,
Question 2. Yes, sir.
on closed system, are we gonna have a process only, not a cycle? Maybe. I don't know if I understand my question.
That's exactly what I'm saying. I'm saying that start with the processes. But remember, a cycle is made up of many processes. Mid-year exam will consist of a cycle with 3 or more processes. You can have 4 or 5 processes, but that is what we will be asking in mid-year. Question 1, we will never ask such a Mickey Mouse question in the test. Question 4, 5 up to 10, these are just Mickey Mouse questions. We can't ask that. So the focus, when you are done with those questions, focus on processes. And then I said that now we are doing question 2 is a process. I'm doing it for you. And then I will be doing question 6 for you is a process, and question 11, which is not here, I will add afterwards. So question 6, I'll do it not maybe today, maybe tomorrow, and then I'll post that worked example on Blackboard so that you can see how to attempt questions with cycles. Okay, so you must know that when you go for a mid-year test, we will not be asking processes, it will be a cycle. Okay, so ladies and gentlemen, without wasting any time, let's have a look at question 2. Is a cycle. The problem with question 2, there's too much English here which can be tricky to some people. And but I'm not saying that I'm going to ask a question like this. Question 11, I will post updated tutorial here for question 11. It doesn't say much about it, only gives you the processes and everything else. But question 2 is actually a bit problematic in terms of the way it's put. But it's English, there's nothing we can do. You just have to understand. Let's start. Air. Now, remember, now we are dealing with air. Air at 105 kPa and 13 degrees Celsius is heated at constant volume. So the first process is constant volume and is heated. It means that the graph is going up. So PV diagram first. Is PV. So the first process is a constant volume process. Heat is added at constant volume, which means we have 1 and then we have 2. And then here is an arrow to show that heat is added. But if heat was rejected, the arrow was going to face down. So the heat is heated at constant volume in a cylinder until the temperature has risen to 840. In other words, T2 is 840. At this point here, we don't have pressure, but we have temperature, which is 840. After that, it is expanded isotropically or adiabatically until the pressure falls back to 105. So what do we do here? It is expanded. Here is the graph expanded, and then the arrow is going down because it's expansion, and the name of the process there is isentropic or adiabatic, and then we must write it here. PV gamma is equal to constant, and this is point number 3. So at point 3, we are told that the pressure is also 105. In other words, the pressure at 3 and the pressure at 1 is the same as 105. The pressure is the same as 105. Following which heat is rejected, or here comes the third process. heat is rejected at constant pressure. So heat rejection at constant pressure, look at the direction of the arrow now. It's going backward. Now heat is rejected at constant pressure until the temperature is 13 degrees Celsius. In other words, T1 is 13 degrees Celsius. So we have a cycle here with three processes. The first process, constant volume, heat addition, adiabatic, expansion, isobaric, heat rejection. Here are the three processes. So this is how I want you to answer this question in the exam, because it's a cycle. So this is how you answer it, because it's easy for me to mark. You say state, a straight line, and then you have pressure in kPa, and then we have volume. There is one thing that I forgot to say, is that you assume gamma is 1.4, R is 294 joules, and determine per kilogram of air. It means that mass of air is 1 kg per kilogram of air. So our units are going to be cubic meters per kilogram. Cubic meters per kilogram. So mass is 1 kilogram. And the last one is going to be temperature in Kelvin. So the first state, the pressure is given as 105. You write 105. The volume, do we have volume? No, we don't have volume. We have to calculate volume. Do we have a temperature? Yes, we have temperature. So temperature is 286.4 at T1. T1 is 105. And then number 3. So for number 3 is T2. We don't have pressure for number 2. We don't have volume, but we have temperature, which is 840. 840 becomes 1113 Kelvin. And the last one is 3. The pressure at 1 and the pressure at 3 is 105. Do we have the volume? No, we don't have volume. Do we have temperature? No, we don't have a temperature. So before you even answer any questions, you must make sure that you complete this table. In other words, you calculate V1, V2, P2, V3, and T3. Calculate those, and then you answer the questions. Now, the first question says, determine the pressure, the volume, and the temperature at the end of each process. At the end of each of the processes. So that's what we have to start. First one, we calculate V1. How do we calculate V1? For all the processes, this formula is valid. P1, V1 is equal to M RT1. We have P1, we have M is 1, we have R is given, we have T1, therefore V1 is 0.8 cubic meters per kilogram. So we have V1. Now, because V1 is equal to V2 for the first process, we say 0.8 here, 0.8 there. In the exam, I just look at this table here, I give the mark, and then I pass, instead of now having to look around the answer book looking for answers. No. Just present your answers the way I'm presenting them. Now we have what? V1 and V2. Now we need P2. How do we get P2? Same formula. We say P2, V2 is equal to MRT2. P2 we don't have. V2 we have is 0.8. Mass we have, R we have, T2 we have, and therefore P2 is equal to what? 409. comma 03 kPa. (409,03). Almost there. Almost there. So now we need V3 as well as T3. As well as V3. How do we calculate V3? Let's check if this formula is going to work for us. Where we say that P2 V2 over T2 is equal to P3 V3 over T3. So these two formulas, this formula and that formula, are applicable to all the processes. So we can use those two formulas for all the processes. We have P2, we have V2, we have T2, we have P3. Unfortunately, we don't have V3 and we don't have T3. We cannot use that formula. But then when you use, you check on a formula sheet, there is another formula there, the one that we used in question 1, where it says P3 V3 gamma is equal to P2 V2 gamma. Unfortunately, you can only use this formula for polytropic and adiabatic processes only. You can't use it for isothermal, isobaric, or isochoric, because for isothermal there is no gamma. For isochoric there is no gamma. For isothermal there is no gamma. So this formula is only applicable for polytropic and adiabatic processes. So we have P3 is 105. We don't have V3. We have P2. We have V2. Therefore, V3 is equal to what? It's going to be P2 divided by P3, 1 over gamma, multiplied by V2. And the answer is 2.11 cubic meters per kilogram. Now, if this is 0.8, we are expecting V3 to be greater than that, which is 2.11. Now our answer makes sense. So our V3 is 211 cubic meters. Now we are left with one property, which is temperature at 3. Temperature at 3, we can still use the following formula. P3 V3 is equal to mRT3. So we have everything except T3. So T3 is equal to 754,68 Kelvin. 754,68. So, ladies and gentlemen, I think with this information now we have answered 90% of the question. All you need to do now is to plug in these values wherever they are.
Sorry, sir. Can you hear me?
Yes.
Sorry,
Yes, I
sir,
can hear you.
could you repeat how you got T3?
Come again?
Sorry, sir, could you repeat how you got T3?
Or T3. Okay, T3, we said that here is the formula. Remember, I said this formula here is use the same formula for all the processes. So P3 V3 is equal to mR3. P3 is 105. V3 is 211. M is 1. R is given, and then we have only one unknown. Alternatively, you can still say P2 V2 over T2 is equal to P3 V3 over T3. You have P2, V2, T2, P3, V3, you can still get 3. The answer is still going to be the same. It doesn't matter which formula you use, you will still get the same answer. Right. So
Okay, thank you, sir.
the second last question, they said heat input to the cycle.
Hello, sir.
Now
Sorry,
we
can you hear me,
see-
sir?
Yes, I can hear you.
Sir, I just wanted to ask why V1 and V2 would be the same, sir, on the table 0.8.
Okay, let me answer that. Can you see this line here? The first process here is a straight line. It's a straight line. So the volume going up, 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 up. The volume is the same throughout. Can you see
Makes
the
sense,
volume
sir.
from 1, the volume 1 to
Yes,
3?
sir.
Yeah, so for constant volume, the volume is the same. The pressure is the only one that changes.
Thank you, sir. Thank you, sir.
All right, so let's go to the second last question. They want the heat input. So in thermodynamic speak, heat input to the cycle, we call it Q net. So in future, you don't say total heat input, you say Q net. The work output for the cycle, you don't call it total work output, you say work net. But in our case, we have a small q because our units are in kilojoules per kilogram because mass is 1. So we are going to say Q net because our units are in kilojoules per kilogram. Similarly, with the work net, you are going to have a small W because our units are in kilojoules per kilogram. So I think the question should be calculate the work done before the heat. You have to calculate the work done before the heat. Now remember, for the cycle, Q net, that is according to first law of thermodynamics. Q net is equal to work net. All you need to do is to calculate work net for all the processes. You add them, and then you say, according to the first law of thermodynamics, Q net is equal to work net. There's no need for you to calculate heat because they are the same or they're equal. So let's start. Work net between 1 and 2 plus 2 and 3 plus 3 and 1. We say work net is going to be work between 1 and 2 plus work between 2 and 3 plus work between 3 and 1. Now we go back to our sketch. Work done between 1 and 2 is constant volume, which is 0 because there's no area under the curve. So this is 0. The work done between 2 and 3 is adiabatic, which is adiabatic is going to be P2. It's not P1 now because we are between 2 and 3. So it's going to be P2 V2 over gamma minus 1 minus P3 V3 plus work done between 3 and 1. Work done between 3 and 1 is what? It's constant pressure. So for constant pressure, it's going to be P bracket V1 minus V3. So this P here, which pressure is this? P1 or P3 because the P1 and P3 is the same, it's 105. So we can either say P1 or P3, any of the pressures because they're the same. So from the table that we have already constructed, we have all the pressures and all the volumes. Gamma is given, the volumes are also given and the pressures. Therefore, W net is 126. Sorry. 126.64 kilojoules per kilogram. Therefore, you say therefore, work net is equal to Q net is equal to 126.64 kilojoules per kilogram. Before we close, let's see why we said for a cycle delta U is equal to 0. We said for a cycle, delta U is equal to 0. Let's see why that is the case. Let's start. You say delta U is going to be delta U between 1 and 2 plus delta U 2 and 3 plus delta U 3 and 1. So we said delta U is the same for all the formulas except isothermal. So we say M CV, we say bracket. Between 1 and 2, we are going to say T2 minus T1 plus the second one is going to be T3 minus T2. The last one is going to be T1 minus T3. So this is the formula for delta U. So let's see why it becomes 0. When you remove the brackets, T2 will cancel T2 because it's positive T2, negative T2. T1, negative T1, positive T1. T3, positive T3, negative T3. Therefore, delta U for a cycle is equal to 0. That is proving the first law of thermodynamics right.